But so so welcome again, everyone. My name's Itzel Torres. I'm with 3C Ren, and today we have our fourth class in our Zero Net Carbon Design series. This one's reducing embodied carbon, and our instructors today are Michelle Zimni and Soham Patel from Imbalanced Green Consulting, and a little bit about 3C Ren if you're new to us. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties. We work on improving energy efficiency in our region and offering free programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars that we pay through our public goods charge found in our utility bills. Next slide, please. We currently have 3 programs. Our first one being the Energy Code Connect, where we offer industry trainings, regional forums, and Title 24 consultation services called the Energy Code Coach to help building professionals navigate the California Energy Code and green building requirements. Our next, our next program is our Building Performance Training Program, where we offer trainings on technical and soft skills related to building science principles and systems for high performance building. And our last program is our Home Energy Savings Program, which serves households that are historically underserved with free and discounted home energy upgrades. And with that being said, I'll hand it over to Michelle and Soham to get us started today. Thank you.
Thanks, Soham. Thanks, Itzel. Hi, everyone. I'm Michelle Zimni, Senior Sustainability Consultant at Imbalanced Green Consulting. And with my colleague, we'll be presenting today's topic, reducing embodied carbon. Soham, would you like to introduce yourself?
Yeah, hi, everyone. My name is Soham Patel. I am a sustainability analyst here at Imbalanced Green Consulting.
Great. Welcome, everyone. We're glad to have you here. I don't know how many of you have attended the previous 3 sessions of this series. We'll be referring to some graphs from previous sessions, so hopefully they feel familiar. But in today's session, we'll be focusing on specifically embodied carbon and strategies for reducing it. We'll differentiate operating and embodied carbon. We'll talk about why care about embodied carbon. We'll look at embodied carbon in the construction process, including trying to understand LCA stages. We'll look at tracking embodied carbon through EPDs, tools for calculating it, and finally strategies for reducing it. I should note that while we're presenting the slides, because we've got Itzel and Soham and myself on the call today, we'll be able to monitor the chat, and please do post your questions as we go. If there's something that seems particularly urgent, Itzel or Soham, we can interrupt sort of the flow of our presentation to get your question answered. We'll also have time assigned at the end of the presentation to allow for a good chunk of time to allow for questions and answers. So with that, we'll just continue on and dive right in. So first of all, I wanted to talk a little bit about differentiating between different types of carbon. You may be familiar with operational carbon if you attended any of our previous sessions. Next slide, please. And that refers to the greenhouse gas emissions, due to a building energy consumption. Once there are occupants in the building, the energy used to run the building. This is different from embodied carbon, which refers to the greenhouse gases emissions arising from manufacturing, transportation, installation, maintenance and disposal of building materials, largely upfront sort of carbon costs for a building. And there's a particular metric that we're going to refer to today I wanted to get everybody familiar with. It's this kg CO2e, so kilograms of CO2, carbon dioxide, equivalent. And we'll see that across a couple of slides today. And it's used as a proxy measure for embodied carbon. And it encompasses carbon dioxide, but also methane and other greenhouse gases. Here's a slide that I'm hoping is familiar for some of you. We're showing operational carbon in a building in the blue. And in previous sessions, we talked about how implementing higher performance strategies can reduce the operational carbon for a building. But here we've added in that green bar area, which is the embodied carbon of a building. And you'll see that it's largely flat across the life of a building. There's a lot that we can do to reduce embodied carbon. And so you'll see here a reduction in that orange arrow down. But ultimately, if we're going to talk about zero net carbon design, we need to get rid of all operational carbon and all embodied carbon. And you might be familiar with some strategies up front that have been addressed. You can zero out your operational carbon by adding a PV system, for instance, on your roof that covers all the electrical fuel for a building. And if it's an electrified building, you're set, right? Similarly, you can purchase carbon offsets for a building that might offset any embodied carbon. But setting those aside, we're going to focus mainly on reduction strategies that'll help get that embodied carbon down so that the cost of the offsets are as low as possible. A quick note about carbon sequestering materials. This is another way to reduce your embodied carbon. And we can see here, by including these kinds of materials, you'll set your baseline for embodied carbon lower. So we can see here that there are two graphs for materials. There's concrete and there's timber. Can you hit the button? So there, great. And they generally have the same pattern where during manufacture, right, there's an increase in the embodied carbon, and then the graph sort of slopes more gently through the rest of the life of the building. The main difference here you'll see is between concrete and timber is this initial phase where the timber is grown, right? In that initial phase, it's drawing down carbon. And so its embodied carbon is quite a bit less at the starting point. So using a product like timber over concrete in your design will help you sort of drop that embodied carbon right from the very beginning. And some examples of carbon sequestering materials are obviously trees, but we also look at hemp, straw, agriculture residues, seaweed more and more, and even algae. So that's just a quick note. If you're wondering what a carbon sequestering material is, this is kind of some brief information about it. So why care about embodied carbon? So it makes up the majority of carbon associated with a building in the first 20 years. We call this the time value of carbon. Before anyone even walks into a building, the building has incurred a carbon footprint from day one. So over a 100-year lifespan, the embodied carbon will become less than 50% of the total carbon footprint. However, in those first 20 years, the embodied carbon plays an outsized role in the carbon emissions, something like 80%. And because we know that carbon emitted now will stay in the atmosphere over time, contributing to the rise in concentrations in the near term, cuts and delays in this process now, sort of delaying our reductions, will reduce the effects and at least buy us some time to find some solutions. So making those decisions upfront now will help us reduce the carbon in the environment in the near term. So that's one reason to care about embodied carbon. Another way to look at it is the overall peak global average temperature associated with different peak emissions. So here you see three sort of temperature ranges projected for our planet Earth, and a peak emission, let's see, that is reached now, and a drawdown that has begun with drastic reductions by 2030 keeps us in this sort of blue range of limited warming under 1.5 degrees Celsius. If we delayed those emissions reductions, those carbon reductions a little bit, say we achieve that same level in 15 to 20 years, we are more likely to remain in the green range of 2 degrees Celsius. And business as usual, as you can see, lands us sort of in this red cone of temperature, future temperatures. that are well above what international bodies are recommending. Next. So another reason to care about embodied carbon is that you might have to. Here we're listing that the state of California has just adopted a new intervening code update, just adopted last month. And it institutes both voluntary and mandatory measures for new buildings in California, and also reuse projects. Specifically, a mandatory measure for buildings that are 100,000 square feet or larger in aggregate. A building reuse project needs to demonstrate a 45% reuse of structures and enclosures. A new project would need to demonstrate using a whole building LCA, a 10% reduction from the baseline embodied carbon of a building. And there's also a prescriptive approach available with its own metric. It's important to note that the square footage for this mandatory measure is proposed to decrease from 100,000 square feet down to 50,000 square feet for commercial projects in the next code cycle. So it's not adopted yet, but that is sort of the trend that we're going to be seeing for California construction. And finally, another reason to care about embodied carbon is the opportunities that it's opening up. So there's a lot of new data and tools that are emerging really rapidly in our field. In this presentation, we'll look at environmental product declarations. We'll also look at some tools for calculating embodied carbon. And finally, some certifications that are available. More and more are coming out every day that help projects and teams sort of advertise the reductions in the work that's being done to make our buildings have a lower impact. Let's take a look at where embodied carbon is. We've alluded to this a little bit. We'll take a little bit deeper dive. Next slide. Oops. So we mentioned the difference between embodied and operational carbon, with embodied carbon generally considered sort of an upfront element in the construction process. If we look at it in more detail, embodied carbon actually occurs across the life cycle stages or phases of a product or building. And here we see the color-coded sort of time frames, where the red indicates the product manufacturing stage of a project. Orange is the construction. Green is certain the maintenance and use of the building, usually associated with operational carbon more than embodied carbon. There's end of life and disposal embodied carbon as well. But it's important to note that really the orange and the red phases are the ones where the greatest embodied carbon is incurred for a project, and that baseline is built into anything that gets built. Next slide. These are commonly referred to as life cycles. So a life cycle assessment is going to have a scope. It might be sort of A1 through 3, A1 through 5. You might have heard something like cradle to gate, which would involve just that product stage in the life cycle assessment. Broader than that, you might hear cradle to grave, which would take into account the product, the construction, the use, all the way to demo of a building. And then there's something called cradle to cradle, which is sort of the gold standard, so to speak, which incentivizes products and projects to think about the circular economy and reuse for any sort of product. So if you wondered sort of how life cycle assessment and these sort of scope reporting labels relate to each other, this is a kind of a simple table to consult. Beyond that, life cycle assessment, you might hear whole building life cycle assessment. So it's interesting that this is a time factored table here, but if you hit the button SOHUM, right, the building part of it relates to which parts of the building you're talking about. So you might consider just the primary material assemblies, the foundation, the structure, the enclosure. And we'll learn today that that's really where the greatest impact in embodied carbon reductions can be achieved. Beyond that, scopes can include interior material assemblies like finishes and partitions. And then occasionally projects also include optional material assemblies like furnishings, building systems, any site work. Taken together, these constitute a whole building. And then if you consider all the life cycles, you might have a whole building life cycle assessment. And it's always important to look at the scope that is labeled on any report that you see. But this is sort of the whole shebang in front of you. And just to sort of cut to the chase for everyone, and we'll dive into it in more detail. You might be wondering, well, okay, so where is all the embodied carbon? Where is the main part of the work that needs to get done? And so we're just going to give you the answer up front. This is a graphic taken from a great report that Rocky Mountain Institute put out about 2 years ago. And they looked across a variety of projects and looked at options for reducing embodied carbon at no to low cost premiums for the projects. And they noticed that really the big hitters are concrete and steel. We know that 10 to 11% of annual GHG emissions, greenhouse gas emissions annually, come from each of these sectors, concrete and steel. Significant reductions can be achieved in insulation selection, and less or so with glazing and finished materials, but they can be important parts of any project that is trying to reduce embodied carbon. Next slide. And with that, I'll hand it over to Soham.
Hi, everyone. So now we're going to get into the building blocks of these embodied carbon analyses, often beginning with this document called an EPD to help track embodied carbon. An EPD, which stands for Environmental Product Declaration, is a document that is standardized to help report the environmental impact about products, and it aims to be comparable as well as verifiable about these impacts. EPDs can be produced for multiple different things. For example, for a single product, today we'll be looking at this foam board insulation produced by Corning. It could be for a product group. For example, the Metal Building Construction Institute puts out an EPD of all metal panel walls to give an idea of what that baseline is for that product group, or an industry average. The National Ready Mix Concrete Association has been putting out these reports for all the concrete mixes in the nation, so we have some sort of national EPD about that. So this report can be produced for a variety of product scopes. And the thing you want to look at is here on this cover page, some key information about the EPD, particularly what is that unit of analysis that they're doing, often called a functional unit, to help you understand what they're running the analysis on. So here for this installation, it's for 1 square meter that they've run all this work on. You also want to make sure you're using the most current EPDs and the right type of EPD. If we look at this one, it's valid from 2021 to 2026, and that it's product specific, which we knew because we were looking at this particular product. And EPDs also tell you what scope for which they ran the analysis. So here, cradle to gate, which is A1 through A3, manufacturing to the gate when it leaves the factory, but it has options as well. So it's also run it for A4 and 5, as well as C1 through C4, which is that building operation piece. If you're using EPDs for some sort of credential, it is good practice as well to see if it is verified. And so that's shown here through this external verification. It is a process that helps with certifications. It can be weighed more as opposed to a non-verified EPD, but this is how you know you're getting the most up-to-date information about a particular product. When you start to scroll through the EPD, you can find out a lot of information, such as what are the material ingredients of it, what the nuances are based on how you spec it, as well as how the product is actually manufactured. But the part that we're looking for is this table here, life cycle impact assessment results. And so after running all their calculations, they're telling us based on the different LCA scopes, how much embodied carbon or how much carbon emissions are associated with each phase, shown here under this GWP, global warming potential, reported in that unit of kilograms CO2 equivalent. And so what we can understand is that in this A1 through A3 scope, manufacturing 1 square meter of this foam board insulation releases 7 kilograms of CO2 into the atmosphere. Additionally, they've shown here for transportation installation as well, adds some CO2 into the atmosphere. But mind you, this is for 1 square meter. So if you were to sort of factor in how much insulation is in a building, this adds up very quickly. And so EPDs can be very useful and be used in many ways. If you're going to use them for comparison, you want to make sure you're comparing apples to apples, have the right unit and scope. If you're going to use them to pursue some sort of certification, you want to check that date of validity. Sometimes manufacturers might leave old EPDs up if the information hasn't really updated. But again, for certification, you want that up-to-date information. And then for calculations, these EPDs are actually built into the tools we're going to talk about here today in our presentation. And so being able to navigate this EPD is helpful when looking at products, but understand that this is sort of the building block for how a lot of these tools work. And now we've thrown this unit of kilograms of CO2 out there. So we want to take a second and talk about what that unit actually means. This here is an image of how much space a metric ton of CO2 takes up. That's 1,000 kilograms. As you can see, it's a sphere that's 33 feet wide. And as a little brain break before we dive into it all, we're going to show you this video here produced by Carbon Visualizations that shows the emissions of New York City, all the CO2 emissions of New York City in an hour, in a day, in a year, and then we'll contextualize that from how much of those emissions the building industry is responsible for. And so for a sense of scale, again, that was an hour a day. And that last scene where you see it covering all of the island is a year. That year scene shows 54 million tons of CO2. That's how much New York City produces in a year. In 2021, the building industry was responsible for 33 billion tons. So that's 54 million. The building industry emits 33 billion tons. And so we're responsible for a scale of magnitude much larger than that. And hopefully that helps you visualize, how much CO2 we're putting to the atmosphere and sort of the urgency around the work that we're doing here. And so to start to dive into that, we're going to talk over what the tools are out there for calculating embodied carbon and what their sort of trade-offs are in their abilities. So this here's a summary table for you all to reference afterwards. But what we see is there's a large variety of tools out there, from calculators to just simple databases. And what is sort of the expectation is that all these tools report a common scope of A1 through A3. Because again, as Michelle mentioned, that's sort of where most of the embodied carbon is accounted for in a building product's life cycle. There's also some of these softwares have custom assemblies, some are free. For example, Athena Impact Calculator shows a scope of A through C, so from building manufacturing to installation, even demolition, and you can build out these custom assemblies. Some of these other tools like Cove Tool, Tally can plug into your modeling software such as Revit, and some of these tools like EC3 tool are databases to help you pick out particular products. And we're going to talk through how these tools can be used when we dive into our strategies for reducing embodied carbon. Another way to think about it is, although there's many tools out there, you want to pick the one that's best for you based on your phase of where you are in your project delivery. These softwares like Athena, Tally, and one-click LCAs, what we often call whole building LCA softwares, are helpful because they can give you a conceptual understanding of where the embodied carbon is in your project. These estimators like Epic and Beam can help you get into that without some of that earlier grunt work to build out your model. And then tools like EC3 and Cove Tool can help you be specific in terms of picking products. And so while Athena might help you understand if you should use mineral insulation or a better product and that impact overall, tools like EC3 can help you pick then that particular product. So understanding as well all these tools out there, but where are you sort of at in your process and the impact they have. Finally, These tools can be used towards certifications. So the International Living Futures Institute has a zero carbon certification, where it requires a reduction in operational carbon, shown by a reduction in EUI. There's no new combustion on the project, and that all the power is produced through renewable power, on-site or off, and adds this embodied carbon component, where there's a 10% reduction in embodied carbon compared to a baseline building, and that there's even this additional requirement based on the square footage for embodied carbon, and that whatever's left is offset through those methods Michelle mentioned of purchasing carbon offsets. Additionally, LEED has been making it easier to start to account for embodied carbon. In version 4.1, you can get points up to 5 for reusing an existing building, or points for running a whole building LCA. They give you a point for just running one, even if you don't demonstrate a reduction in the embodied carbon. Or you can also use the process of selecting products shown through EPDs that have a lower global warming potential compared to some standard product. And so in this case, you have to pick 20 different products, which is feasible as more and more EPDs are being put out there. And so after a quick summary of the tools, we're now going to dive into how these tools can be used in 3 different strategies for lowering embodied carbon.
Thanks, Soham. Before we do that, can you go back a slide?
Oh, yeah.
I know at this point in the presentation, it can often feel a little bit like a fire hose is coming at you. So I wanted everybody to take a breath and maybe give folks an opportunity to chime in on the chat, because we're not seeing a whole lot of activity yet. And we do want to see questions. If you know what this kind of diagram is called, will you put it in the chat? I just want to see how familiar people are with some of the metrics that we're going to be talking about. Anyone? Take a best guess. What's this kind of graph called? I'm not seeing anybody. Okay, we'll find out. All right, thanks, Soham, for the pause. We can move forward. So we're gonna look at some strategies for lowering embodied carbon. Broadly speaking, we're going to cover 3 strategies. Let's see, who calculates the baseline building against what you're building with compared to certifications? Okay, we'll definitely can take that up in the end. We're going to talk about 3 broad categories of strategies. And again, we're pulling these from a Rocky Mountain Institute document. One is called whole building design. And some of the details of that is that project teams are looking at initial decisions that affect the fundamental design of a building. So examples might include adaptive reuse, reducing the overall square footage of a project, using more efficient structural systems or alternative building techniques, using prefabricated systems or components, and designing to upfront to minimize waste. So that's sort of our strategy 1, and we'll be going through each one of these. The second strategy that we're going to take a look at is called a 1-for-1 swap. And so this involves direct replacement of one material with another that'll meet the same functional requirements of the original design, but effectuating a lower global warming potential overall for the project. Examples might include choosing a cellulose insulation in place of a petroleum, foam, typical foam insulation, or choosing an LVL beam in place of steel. A third strategy that we want to talk about today is looking at using specifications to reduce embodied carbon. And so this is accomplished by establishing a value or a limit for a material characteristic that will dramatically reduce the embodied carbon. Examples include specifying a desired % reduction in global warming potential for a given cement mix, or specifying steel rebar products that have lower EC, maybe something below the Carbon Leadership Forum or CLF's benchmark. So taking these in turn, the first method that we're going to look at is that whole building design. And we're going to use a tool that we've talked about, the Athena whole building calculator, to walk everyone through a project and how we've used these together to kind of use that strategy and the calculator to result in lower embodied carbon. So this is a case study, a project that we're doing in Santa Barbara County. It's 10,000 square feet. And sorry. And to illustrate this method, we'd like to highlight a local project, right? You'll recall the strategies typical for this method include here on the right, the adaptive reuse. These strategies are most effective on foundations and primary structural assemblies. For this project, in addition to an existing building, I mentioned it's 10,000 square feet, a project team set out to design the primary structural systems using lower EC options with an eye to eventual zero carbon certification. So we are pursuing the ILFI zero carbon certification. And we were able to model the building using Athena and materials that might be typical for a baseline case. For this project, we consulted with the architectural team, other projects that they've done of a similar function. And their baseline construction case included a concrete foundation, hollow steel columns and beams, and light steel studs. As we'll show, as we demonstrate this tool, we ended up with a proposed construction that included a modified concrete foundation, glulam columns and wood eye joists, and LVL studs. So next slide. Just a quick summary of the Athena tool. It's a free piece of software available online. You can use it for a variety of certifications and CalGreen as well, documentation, those mandatory measures that we talked about. It's appropriate for all phases of design. One of the key things about this estimator is that it has set assemblies in a menu that you can select from. And it provides cradle to grave life cycle analysis for the whole building. So this is what it looks like. So, great. It's structured with a typical sort of trunk and branch structure, like an energy model, if you're familiar with that. So it's a building tree organization. You can see here we have a proposed building with 4 assemblies underneath it, and then a baseline building with 4 assemblies, including columns and beams, roofs, foundations, and walls. And so the user can build a baseline model and a proposed model and then compare the two within the estimator. You can define the wall and roof assemblies from a menu or with specifications that you bring to it. The wall assemblies include openings for basic window inputs, glazing, and the foundation can include slab, footings, grade beams, pad footings, and rebar. Here's a look at the sort of the detailed window functions that you'll see. Here we built a wood stud wall, selecting from the menu. It then opens another window where you can specify more about this wood stud wall. It's load bearing or not. Is there sheathing, stud spacing, stud thickness, etc. And then you can also add layers to it. So here we're showing the exterior finish is a stucco, but you could add in air barriers, sheetrock, latex paint, and you just build out the layers of your assembly in within the calculator. If you don't see a ready set assembly that you want that matches your proposal or your baseline building, you can also input user-defined components. Here, it's most common with a concrete mix, for instance. So we had a user-defined concrete mix and use the design library. And you input the list of components on the left there. You can choose how to enumerate it here. We did it by % weight. And then we were able to input sort of the component weights and total weights on the right-hand side. And where we got these numbers was from talking to local cement and concrete providers. It took a little bit of doing to find someone that kind of knew what we were talking about and ultimately said, oh, that sounds like the recipe or the list of materials that we produce for regional materials lead projects. And so we said, yeah, let's take a look at that. And it turns out that by just pulling up this sort of ready-made recipe that they had and documentation for a lead project, we were able to glean the information we needed, put it into the Athena calculator, and produce the output report that was needed. Next. So I talked about reports. Once you've built all the components and assemblies that you're wanting to compare, and again, you can define whether you're doing primary structural assemblies, secondary, internal materials or interior materials or not. You get to this page where you kind of tell it, okay, now do the analysis and give me a report. Here you're defining the system boundary A through C. We pulled up the reporting format as a LEAD format, but this also works for the ILFI, the International Living Future Institute's reporting requirements. And it'll export the data into a CVS file, which can also be used to customize graphs. Here we have a bar graph resulting from this project, and you'll see the blue is our baseline project, and we modeled the foundation, the walls, the columns and beams, and the roof. The data in the blue box there shows the carbon emitted for those sections of the building with a total on the right-hand column. We then go ahead, Soham. We then also generated bar graphs for the proposed design. And here I should say something about the proposed design. Hang on a second. We analyzed hotspots and we realized, okay, our levels are pretty high in this blue baseline case. Let's look at, the glue lams and the wood stud construction and maybe an exterior continuous rock wool insulation instead of the polystyrene insulation. And that generated these orange bars. And so you'll see that the data is also reported out by assembly with a total on the right-hand side. And then it gives you a handy dandy, visual representation of reductions per assembly, but it also gives you numerical reductions. Here at the bottom, you'll see 24, 20, 73, 1% reduction with a total for the entire analysis that came in just under 20%. So if you click one more, you'll see the 19% there on the right-hand side. So this is really helpful in reporting. As Soham had pointed out, some certifications require that you demonstrate a 10% reduction in your primary assemblies. And this is the kind of calculation that could be done to render the documents for a certifying body like ILFI or LEED to show that you're hitting sort of these minimum thresholds for embodied carbon reduction. I see a lot in the chat. I wonder, Soham, should we just take a pause? Have you guys read through the questions? Are there things that we should address in the near term?
I've read through the questions. I think we can save them for the end. I think some of them might get answered by some of these other strategies.
Okay, great.
Yeah.
Right. Thanks everyone for chiming in. We are tracking the questions. So that's sort of a quick presentation of how a whole building design strategy might work. A tool that's useful for sort of calculating and crunching the numbers that would need to be done for reporting. And now we're going to shift gears to the second type of strategy, which we called the one-to-one swap. And here we're going to then also fold in the embodied carbon. Let's see, the embodied carbon in construction calculator tool, the EC3 tool, which is a database. Here we're using another, so we're going to blend those two and kind of show you how they would work together to run this kind of strategy on a project team. Here we're using another project that RMI presented. It's a mid-rise stick-built, 4 or 5 story multifamily building. The project was able to achieve an overall 41% reduction in embodied carbon. And they achieved that by looking at a range of materials. So here in the green box below the graphs, each one represents a material category. So insulation, concrete, rebar, flooring and paint, glazing, doors, that's an unusual one, and steel. And they saw that just by kind of playing with products in a database, they were able to identify the greatest reductions in switching out the type of insulation that was used. Specifically, I think it says something like 16% of embodied carbon reduction by selecting a particular insulation. So let's take a little bit closer look at insulation as an example of a one-to-one swap. So, and if you're not familiar with it, insulation selection can actually make a huge difference in the contribution it makes to your overall embodied carbon. If you look at common foam products like extruded polystyrene, XPS, some spray foam products, you'll see that those are among the highest embodied carbon products. And I should say that this data is standardized for functional unit, but also for essentially R value. You'll see the data uses a little bit different metric, but from R, it's an RSI, but it is standardized. And so the numbers here do actually represent real differences between products. In the mid-range, you'll see products like mineral wool, an extended polystyrene foam, and EPS, which is one of the products that's really working hard to reduce the embodied carbon it presents for projects, and standard fiberglass bats. On those carbon sequestering materials we talked about a little bit earlier, cellulose, hempcrete, straw bale insulation systems are product decisions that teams can make to dramatically reduce the embodied carbon up front as you're building out sort of your components for a project. So with that, let's take a look at how we might compare swapping one kind of insulation for another, or if we decide, okay, we're going to do a mineral wool insulation, which one should we do? Those kinds of questions can be answered by looking at a database tool like this. And this is an EPD database like EC3. It's still in beta. It's free for all users. You just kind of sign up and get an account, log in, and you'll land on this page where you have an option to select what kind of material you want to look at today. So today we're going to look at thermal and moisture protection. You can select insulation, you can select the type of insulation, and here we're picking board, and you hit next. The screen will pop up where you can give it a little bit more information. Here, among board insulation, we're picking XPS to kind of give us maybe a baseline case, maybe a typical construction for this building would be an XPS foam. It's you can select where it is in the building. Is it an interior wall? Here we're selecting exterior wall. And then you can even select where you want it to be manufactured, which will cut down on transportation embodied carbon. So we're selecting the United States and we're searching. Oh, I'm seeing that somebody says very small slides. I don't know if we can enlarge them or not. You might be able to in your view. You can kind of select how to enlarge it all. Here at the bottom, then it'll generate a list of products that have EPDs in their database. And it's tempting to dive in and open those up and start looking at them. But what we really want to direct your attention to is this graph in the upper right-hand corner, which shows the range for all the products across this category that have EPDs in the database. And in case anybody was wondering what this is called, it's a box plot. Let's take a close look at it. Basically, that green bar in the middle represents the reporting data for 80%, kind of the middle 80 or 60% of the EPDs in the database. So between the 80th percentile and the 20th percentile, will report within that range. And so it's a kind of a good averaging representation of what you can find in the database. Additionally, the upper and lower ranges are represented by these bars. And it gives you a little bit of idea of like, well, how well represented is this kind of product in the database? And was there one more we were going to point out? No. Okay, that's it. So here, that's a quick run through box plots. You can play a lot with it within the EC3 tool to find out a little bit more about what you're looking at. But here, if we take the box plot from the XPS rigid foam that I had walked you through, that upper right-hand corner, you'll see that as a category, the range is sort of 1 to 1.25 kilograms of CO2 per 1 square foot. Click SOHUM. And within that range, the lower level, which they call the achievable level of embodied carbon, comes in at just under 1 kilogram of CO2 equivalent. If we pulled up the similar box plot, I went through the search for a mineral wool product, you'll see that overall, on average, mineral wool products will report much lower embodied carbon. Their range is in sort of the 0.3 to 0.6 kilograms of CO2. So you're going to get reductions right up front. And with their achievable at the low end there, pretty significantly lower. We're looking at maybe a 70% reduction just on the insulation. And it's a way to quickly look at, okay, where do we really want to dive in? If we think mineral wool is a reasonable product selection for a project, all things equal, then you can go through and look through each of those products and some of the more specific characteristics that they might present in terms of manufacturing, transportation, thickness, R value. But this gives you kind of a quick glance where you could swap out an original material that you were planning to use for another that would really help you reduce carbon on the project. And I'll hand it over to Soham now to look at the third method that we're talking about.
Thanks, Michelle. This third method about specifications, we'll call smart specifications, has to do with, maybe you weren't able to get those early decisions in, but you do want to make some sort of impact when it comes to embodied carbon. We can find that through our specifications. And so this involves establishing some value or a limit for a characteristic about a material product that has an impact on embodied carbon. So this can be directly the global warming potential, the GWP of a product, but it can be things as well as, for example, where is it manufactured, how is it transported, some other things that have an impact on the product's global warming potential. So this can include asking for EPDs. A lot of manufacturers are putting them out there, but to help drive market change, it can be part of your bid package so that when you're comparing your packages, you have you can make an informed decision when you provided the EPDs for these products. Like I mentioned, you can specify a maximum transportation distance for where these products are sourced from. For example, picking a locally harvested timber product is better than one from much further. But today we're going to dive into particularly prescriptive specs and this initiative to move from prescriptive to performance specifications, as well as how to set a global warming potential limit for a product in a specification. We're going to be referencing the work of two bodies, this National Ready Mix Concrete Association report to how to improve a concrete spec, as well as what Structural Engineering 2050, which is the engineering equivalent of Architecture 2030, has put out in terms of specifications for these structural materials. We're going to tie it to this Rocky Mountain Institute case study where they use this process to optimize their specification and their selection process. They picked, in this case, concrete. They had an overall reduction of 46% by looking at concrete, rebar, glazing, and insulation, with the largest reported reduction of 32% in the concrete alone. And so to cut to the chase, the way they did that was by selecting a mix that had lower amounts of cement in it, as well as lengthening the sufficient strength date requirement from 56 days to 28 days. And we'll talk about why that trade-off might want to be made, even if it has an impact on the project delivery schedule. So from a quick, sound off in the chat, I'd love to know who here has read through their concrete spec that they've put out in the last year. But that's kind of difficult work, but that's the first place to start. If you're comfortable with prescriptive specifications, the National Ready Mix Concrete Association has put out this guide where they take a sample cast in place concrete spec and they have their sample spec language and then add their commentary for how editing parts of your prescriptive spec can have an impact on embodied carbon for a concrete mix. And so if you go to this document, you'll find that straight up right there. Part of what informed the Ready Mix Concrete Association's work was this report, which if you want to get into the nitty-gritty, more than welcome to look it up. But what they were finding is that architects and designers had these assumptions about what makes a good concrete spec. For example, having a minimum cement content. And that is because having enough cement gives it a sufficient strength. But cement is the largest contributor to embodied carbon when it comes to concrete. It's the most intensive component, energy-intensive component of concrete. And so what they do is they go through and explain, sort of debunk the myths that we might have about concrete, and mention in this case, strength can also be achieved by using more aggregate or using more admixtures, often called SCMs or supplementary cementitious material. And as a way to address this, they then have these opportunities. For example, because you specify only the age by which the sufficient strength has to be met, not the minimum cement content. Because usually if you keep a short age, for example, 28 days, they're going to up the amount of cement to make sure it reaches that strength by that age. Or you can specify an age later. For example, 28 days, you add admixtures. If it's feasible within the project delivery, it's a great way to help lower that amount of cement. And they have some other examples as well for if you've ever gotten into the water to cement ratio or about those SCMs. Going through this table helps you understand sort of the impact of these choices. Although, after putting out this report, the concrete industry is doing this initiative to help move specs away from prescriptive towards performance specs, prescriptive to performance, called P2P initiative. And so what they found was that the specs, as we already sort of started to allude to, puts limits on categories when maybe there doesn't need to be that limit. And so here we see a summary again of those sort of assumptions or limits that are often found in your spec. And what they're sort of arguing is that we should capitalize on the expertise of the manufacturer and the producer and the contractor and what they know about their product to help us pick a better cement mix. And so, as already mentioned, set strength based on need and rely on the manufacturer and contractor to get that sufficient strength based on what they know through a performance spec. And so an example of this approach is setting a GWP limit through a performance specification. And so this here is an excerpt from the Marin County Code, where Marin County has set since 2019 a global warming potential limit on their concrete mix. So if we look here, they say based on some specified strength, which often comes from code or application, they have set an embodied carbon limit. They also additionally have added this cement limit. Now, I don't think any of us are in Marin, but the way we can start to accommodate this approach in the way we run our practices is using the EC3 tool to find that baseline. So for example, running a search for ready-mix concrete for the region you are in California and just sort of seeing what that industry standard is, and then based on that, setting some reduction for your product. Now, again, this does require some expertise, so talking to your concrete manufacturer and looping them in early can help you understand how do you set an achievable limit in your concrete spec. Now, if you're not ready to get into the weeds with some of these high-value structural materials, there are some easier ways to start to get into it. For example, like I mentioned, asking contractors for EPDs in the bidding package is a great way to start. By asking for EPDs, it helps you inform your decision without maybe investing so much time into tools and softwares, and it can help drive market change by creating that expectation for EPDs. Additionally, you can also start to use this approach for other building material categories. For example, in your envelope and your finishes. So picking, specifying that all timber is Forest Sustainability Council, FSC certified, or picking products that have a positive impact on indoor air quality through Green Label Plus. Declare is also another certification you can look at for responsibly produced products, as well as UL certified. And so again, we talked about concrete and steel, or concrete here because it's a big hitter. You can get into it in other material categories like envelopes and finishes.
So just a quick takeaway for everyone. We'll be wrapping it up. These are the familiar circles we showed at the front end when we said big hitters. And this is sort of a summary table of reductions in embodied carbon that can be realized in each of these categories. Things that you can do right now, taking away from this presentation, is number one, reuse buildings or parts whenever you can. So the greenest building is the one that doesn't have to be rebuilt, right? Consider reducing the amount of concrete or steel in your building. Specify a lower embodied carbon concrete or recycled concrete or recycled content rebar. Selecting lower embodied carbon materials for, insulation, sheetrock, flooring. Those are those one-to-one swaps that we're talking about. And consider wood or mass timber products for the structure, especially Forest Stewardship Council FSC certified wood, because their growing and harvesting practices are shown to reduce the overall carbon emissions of the forests that are managed under their certification body. And with that, we will be able to open it up for questions, but I wanted to let Itzel give everybody a little bit more information of where things go from here, and then we'll spend some time fielding your questions from the chat.
Thank you so much, Michelle and Soham, for a great presentation. a little bit about what's going to happen next. If you have any questions about AIA learning units, feel free to email me. There is one AIA HSW learning unit available for this course, but if you've been taking the courses throughout the series, you should be able to get five of those learning units to complete the 5 hours of zero net carbon design required. So any questions about this, just send me an email, and you'll also be getting the slides, the recording, and an additional survey in the next couple of days from this course. So be on the lookout for that. And just a little bit more about our upcoming classes. If any of them sound interesting, please make sure to register for that. I'll drop our calendar in the chat so y'all can look at that whenever you have time. But with that, thank you again, and I'll hand it back to Michelle and Soham to answer questions.
Soham, can I ask you to go back 2 slides, the bottom, to the list of events? That last event on September 19th, although it doesn't say it in the title, there is actually part 5 of the Zero Net Carbon Design series, where we'll be looking at regenerative design in practice. So if you've been attending all 4 up till now, that's sort of the logical conclusion, the 5th session of the series. Awesome, thanks. So I've been looking at the chat, and I think we've got some good questions that either myself or Soham can field. Top of the list is who calculates the baseline, in quotes, building against which a given project team's building might be compared for certifications? This is a great question. And it varies depending on maybe what kind of certification or what kind of documentation you're trying to provide. Generally speaking, there's an organization called the Carbon Leadership Forum that has analyzed a broad spectrum of buildings, and they have provided sort of baseline numbers for types of construction. That said, for instance, in the project that we did a case study for using the Athena calculator, we didn't have anything that we could compare to that list from CLF. And through some dialogue with the certifying body, back and forth, they said basically, if you can demonstrate that the baseline building that you're modeling has basis in reality, it's the kind of building that would be built for the function and the size by your design firm or in that region, and then you can show differences in your proposed design, you can submit both of those models to us to demonstrate the reduction. So the kind of 2 ways that you can get at what that baseline building looks like. I should also note that the field is evolving quickly enough that maybe tomorrow I'll be wrong and that there'll be a standardized list of baseline buildings, but that's still in the works. And it's really speaks to sort of the dynamic nature of the field of calculating and documenting embodied carbon across the construction industry. But great question. I'll hand one over to you. Oh, go ahead.
I was going to say, I was going to next address Jeffrey's question. I consulted with our local Athena expert, Jennifer Rennick, about your question. And the question is, can we model REBAM, bamboo reinforced concrete, cyclopean concrete, compressed earth blocks? To answer your question, in the Athena software, the sort of key piece about how they're calculating is that cement content. So for example, for bamboo reinforced concrete, when you're in there setting your assembly, if bamboo isn't in there, if you're going after certification, you'd have to produce some sort of narrative about, like, here's the bamboo, here's what we're putting as our embodied carbon. Athena most likely doesn't have it built in. You mentioned cyclopean concrete, which for context, it's the use of large stone rocks that are assembled as a wall with concrete then poured to shore it up, or compressed earth blocks. I would imagine, and again, Athena doesn't, have these as preset things, but for the latter 2 products, you would be using some cement. My understanding is compressed earth blocks at least have some minimum cement content. And so, that would be easily accommodated into the Athena software. Then you would have to do some finessing to account for those other products that go into the cement or into the concrete mix. And so not built in, Jeffrey, but it can be accommodated if you're careful about it, right? And if you're going after certification, you have to produce some sort of narrative. But again, the key part there is with the concrete mix, they're looking at those specific products in there and their contributions. And so if there's cement in it, it can be accommodated into the concrete input. I hope that gets you an answer, Jeffrey. Okay, awesome. And then I'll address the question 1 that Liam Buckley put. I think you're better suited for number 2. The arrow is meant to say applicable for all phases of the time, not saying it's only that Athena, one-click LCA, and Tally are only for useful in construction. More that it has the capability, and most likely, obviously depends on the way you run your practice, it most likely is helpful in all of those phases. And that some other softwares maybe can't do every single step you would need to get through from beginning to end. And I hope that addresses your first question, Liam.
And so I'll jump in on the second question, just for folks who haven't read it themselves. What's the difference between the whole building LCA group of tools, I'm guessing, and the estimator group? So can we bring up that slide quickly so people can see what we're talking about, right? The question says, it appears that each tool is either one or the other, but cannot be both. So the short answer is, yeah, I think that's right. That said, the same way that the EC3 tool I mentioned is in beta, a lot of these tools are rapidly developing. So I think the beam estimator is maybe the one that was on our slide, and I'm going to give him another minute to pull it up.
Here we are. Oh, you didn't jump to it. My bad. There we go.
There we go. The whole, yeah. So the estimators like Epic, and then Beam is a contractor, not specific, but focused or specialized for contractors to use, where they might be, pulling up 2 flooring materials, and they don't want to get into the nitty gritty of looking at box plots and stuff, and it quickly delivers EPD type of information. So I think the main differential that we might see is, well, 3. I'll say 2. Modeling software like whole building LCA software like Athena, or these plugins from Revit into Tally or one-click, where you're building out more than one assembly and getting sort of a whole building, depending on the scope calculation. It can be broken down into components, versus these databases that might estimate at different levels of specificity using better or worse collections of EPDs in their database to give you more specific, but less maybe broadly relevant for a project data. So you generally can't be both, although the EPDs of an estimator or a database are embedded in the whole building LCA tools. So when you pick the assembly, they've embedded EPDs into their software already. I hope that makes sense.
Awesome. Let's see. We have a question from George. How does on-site material like clay, straw, and EcoNest builds, how does that fit into the Athena software and what you've presented? Somewhere between straw bale and cellulose, with extra credits for on-site clay use? That's a great question. I would offer a similar answer to what we said to Jeffrey. I guess there's also something useful in pointing out, like, for example, the Athena building estimator tool is what is sort of being promoted by the state of California for a very large application. So, it's not meant to be like the software you use on the cutting edge. I'm sure for some of these more particular cases, you'd have to dive into a nitty-gritty or get a consultant. So that's to say, Athena could, but Athena in particular is being developed to be used across the state for code, for meeting building code. And so it would be, I personally don't know unless, Michelle, you can offer, for example, on-site credit, the use of on-site materials.
Yeah, my sense is that to the extent that these pieces of software are built on EPDs, right, they use data, and companies spend a lot of money to produce EPDs so that they can kind of get into this game or process, so to speak. I don't know that there's an EPD on clay right now. You can make an argument, you can make a narrative that on-site clay has no transportation. It has very little production greenhouse gases, maybe getting a machine on site to dig it. and deliver it from one part to another, or if you're heating it in some way to create a byproduct. But there isn't an easy way to account for it at the moment in a lot of these tools because they are EPD based.
Right. Then
Good on ya. I want to visit all these great project sites that are using straw bale and cyclopean concrete. I love it. Sorry, I cut you off there.
Oh no, I was gonna say George offered a last comment, and that digger could be human or electric, right? And so, I mean, in a way, I could imagine you producing your own EPD for this product, right? Like you go through the process, you list what you do and what your estimated impact is, and that could be the basis to then put it in. But I think the point Michelle makes is important, that they work off the EPD, which is why we spent that time in the beginning sort of talking through what goes into that.
Good questions. I love thinking outside the box. Okay, let's see. Are there any requirements for residential, single family, small number of units, multifamily? I'm assuming that you mean California requirements for embodied carbon reduction. Is that correct? I'll assume so. Yes. At the moment, the quick answer is no, except if you're building a multifamily project that's over 100,000 square feet, then you will be subject to it. And I'll double check that with Jen, our code specialist, and let everybody know if I'm wrong. But that's my read of that intervening code update, where they said 100,000 square foot aggregate projects will trigger this sort of embodied carbon documentation, reduction and documentation. I don't think that it matters if it's, office space or retail space. I think it's just overall 100,000 square foot aggregate.
Yeah, and I'll also offer that is most likely the case, given that energy code versus building code, multifamily is lumped in with non-residential.
Right.
I imagine we'll get more clarity on that as we move forward, because non-res versus housing is under different agencies. But I guess if you were wanting to get the most up-to-date information, this requirement is particularly in Cal Green. So whatever Cal Green dictates in their process, that's where we're sort of pulling this embodied carbon code from.
And it's brand new. Like we said, it passed like last month. So
yeah, a lot to be figured.
Other questions? Well, we've had a blast. Seeing none, we've had a blast helping introduce everybody to embodied carbon. If you're new to it, hopefully you got 2 or 3 points that you can take away. If you are a little bit more versed in the topic, hopefully we provided enough in-depth information and applications to case studies that we kept you interested. It's been a pleasure having you all here. As Itzel mentioned, there's some follow-up materials coming from 3C Ren. We will also be providing the slides within sort of the next week or so that you can have all this material for your own reference. And with that, I'll say goodbye. Soham, if you had any closing remarks, I'll hand it off to you.
Yeah, I just wanted to mention that very early on, and I'll send this again, there's this handout that we've produced that has all the terminology explained out throughout these 5 presentations in ZNCD. So if you need a refresher, I just dropped that PDF again in the chat. If you want to remember what GWP stands for, you'll find it in that document there.
Awesome. Any last words, Itzel?
No, thank you everyone for tuning in. Great training.
Great. Have a great afternoon, everyone.